All right, how y'all doing? It's good to be on an actual stage again instead of Zoom. As you guys know, in 2020, the retailers reported a disproportionate sale of tops versus bottoms. It was like a big difference. Anyway, it's good to be here. I appreciate S4x22 for having me out, and let's dive into it. So if there's one takeaway about me, if it's fuzzy, I'm on it. I've always been at the front end of new emerging technologies. Previously, I was working on IoT and now edge computing, which is kind of an extension. Been in R&D and CTO roles for a long time, so let's kind of dive in as we go. I joked back in 2017 that we were in the AOL stage of IoT. Early days of the internet, people get these CDs and they load them in and be able to connect online, and they use keywords. You have to go for everything through AOL. It was kind of like a lock and play, and then all of a sudden, this funny word Google comes along, and people realize, oh, I can just connect directly to the internet, no problem. And so things obviously changed, and the internet became what it is today. IoT too, it's a big change in how you do things. Obviously, from an industrial controls standpoint, it's this balance of connecting formerly unconnected systems to get some sort of business value, but of course that introduces risk. So we've seen this change happening over time. It didn't hit the $50 billion or 15 billion devices by 2022 projections. It of course is happening, but it's taking time. And part of the reason why IoT is taking time is, obviously there's a security element, but it's also this notion of use case. Is there a reason to add risk and complexity to my life for value? And people, it's complicated when you bring different stakeholders, whether it's from the operations side, the IT folks, the line of business. And so this is a big reason why it's been a challenge. A lot of IoT projects start out with what I call cheap edge, easy cloud. Someone grabs a Raspberry Pi and starts tinkering with it, playing and figuring out a use case. And public cloud, or the cloud resources, there's great resources out there, but the whole play is make it really easy and inexpensive to get data in, and very expensive to keep it there and get it out. And so this notion of cloud lock-in, of course, all the clouds are offering their edge offers today. There is always this balance of kind of easy button versus lock-in. It's a personal choice. I think it's really important to be thinking today about how do you meet all the different needs as we see more and more applications being distributed, while also avoiding lock-in to any given back end. I mean, of course, in the industrial world, we've seen this kind of lock-in for a long time, and the way that the controls players have done things. Why do we have so many connection protocols? Because everybody created their own protocol to lock you into their stack. But the market's changing. The market now is more about winning by merit, not lock-in. There's so much innovation happening now that you have to keep moving faster. And of course, we've got to protect the critical systems out there, but things are changing. So if you look at edge, people are like, edge computing. Oh, there's the near edge and the far edge and the thick edge and the thin edge and AI edge and industrial edge. The reality is there's one continuum. On the far extreme, you've got field devices. It could be a smart thermostat. Of course, you've got different industrial controls systems and sensors out in the industrial space. Very constrained, very fixed in function. On the other extreme of edge, you have regional data centers, for service providers delivering lower latency services, or like streaming video to lots of users. Latency sensitive upstream, trying to deliver workloads. Latency critical, on-prem. I've talked with, I was previously at Dell Technologies, so I kind of come more from the IT side, and I was at a customer site, and some of my colleagues were telling the customer that we can manage your PLCs from the cloud. And I'm like, I just want to crawl under the table and hide. But it really is about this continuum. What we're seeing is that edge, we have kind of the operations world, the ICS world, IoT in many senses kind of coming up to this meeting point. And then we have the IT principles, what we've seen in the data center for the past several years, coming down from the cloud. And in the middle, there's this trade-off that you make between you know, all these different trade-offs of latency critical, latency sensitive. Am I in a secure data center or am I not? Will I always have connectivity or will I likely lose connectivity? So a lot of factors, and we'll talk through kind of how these considerations are addressed by this EvoS operating system that we've put out into the Linux Foundation. So a lot of users don't really care about security and orchestration management up front. They care about a use case. I've seen a lot of people, so starting with IoT, people come to me and say, hey, I want to buy some IoT. So like, okay, what color would you like? I mean, it's not one thing. It's not like it's a concept. And now people are learning how to spell edge, and some people have got like a really good use case, but that's where it starts. And then you care about an application, you care about, to a certain degree, hardware and the right specs and compliance and things like that. But you're not really thinking security yet. And then at the kind of tail end, after you get through a couple POCs and whatnot, then people really start thinking about security. And why is this the case? Because people want the easy button up front. And that's why people start with cheap edge, easy cloud. Or I also joke that the cloud providers are providing IoT gateway drugs to users that kind of suck them into their ecosystems. And then you're locked in once the data starts flowing. So it's really important to be thinking about, obviously, security and orchestration early, but then also you have to give people that usability and the ease of developing new applications so that they can just kind of hit the ground running. So I see 4 unique paradigms across edge that continuum given trade-offs. So far extreme embedded devices, all through controls and stuff like that. Today, purpose-built, fixed function. When it comes to consumer world, obviously all the devices, everything's unique. Code is custom to that device because of the resource constraints. It is what it is. There are some evolutions happening in terms of kind of unikernels and different types of software elements, but today it's embedded. The other extreme, we've got data centers. Generally a solved problem. We do have evolution happening for edge with Kubernetes coming down and SD-WAN, no network perimeter, especially with more and more kind of hybrid work environments. But generally, well established. Same thing for mobile devices. Well established ecosystems around Android and iOS and Windows and whatnot. PCs. Not to say it's not without challenges, but distributed edge, that space in between. For kind of IoT use cases, edge AI, and the like. This is unique because it's like I can use the data center principles. I'm not embedded. I have resources to run virtualization, containerization, et cetera. But I also have to assume I'm not in a physically secure data center. I don't have a network perimeter. I have to assume I'm going to lose connection to the back end. And I have to work reverse, through firewalls and NATs and all that. So it's very similar principles in terms of kind of cloud and IT principles coming down towards the ICS world, but it's necessarily different foundational elements. And so that's what we're going to talk about with Eve. There's the old keep it simple mantra. The other big thing I would say is keep it separate. Very, very common practice in the IT world is to separate out the infrastructure plane from the application plane. But with IoT, and certainly with ICS, we've seen a lot of siloed stacks over the years. Kind of purpose-built, definitely a lock-in situation or high potential for lock-in. Because it was easy, you build relationships and you kind of build out that full stack, and if it works for you, you tend to stick with it. But in the world of software-defined infrastructure and continuous delivery of software and kind of this whole notion of cloud-native software and extending that to more places, it's really important to separate out these 2 planes. You do not want your core infrastructure out in the field when you're trying to define new types of use cases and applications and work with all these different stakeholders. You do not want that hard coupled to your applications because you're driving a truck out to replace that infrastructure if you want to switch. So more on that as we go. But so when we look at edge deployments, I mean this is kind of the classic Purdue model, but we look at edge deployments. Typically, of course, there's the control systems. We are seeing some blur starting to happen between traditional control systems and an IoT or edge node, where the physical separation starts to become virtual separation on one box, with like soft PLCs and things like that. It's still pretty early. So where we would see these types of deployments pick up would be right over the control layer. Could be a gateway, it could be some sort of security node doing segmentation or a protocol inspection, things like that. I might be running applications, on consolidating applications on an edge node a little further up in the stack. I could be doing more network segmentation. A lot of times, of course, in the operations world, it could be that OT completely bypasses the IT side, just goes straight out. If they are cloud connected, could just be all entirely on-prem. But increasingly, we're seeing kind of this hybrid where the OT side is sort of punching through the DMZ to the IT side. Networks are segmented, and then you start seeing kind of the data side on the IT side. There's no single answer. The whole point here is that you have to architect for all these different permutations. Same stuff applies whether it's a factory, a building, a refinery, and then you can take it also out to the field, like on a truck or a wind turbine or whatever. But these types of patterns we're seeing. So we've had all this, the history of lock-in. Whether it's the controls players, the clouds are making that kind of play. But once you get to the point where there's so much data on networks and there's so much innovation happening, and while the cloud is super powerful, once that data really starts flowing, and after you got the easy button and got started, then you get the bill. And that's why we're seeing all this conversation around edge. It's about latency, of course, but it's also about bandwidth and just the cost of moving data around. And so that's why it's just super important to be thinking, how do I prevent myself from being locked in today? So I use this analogy for like riptides. So a lot of times, so if you get caught in a riptide, your inclination is to swim towards shore to save yourself. That's when people get tired and very often drown. What you're supposed to do is swim sideways. And so, I look at where the market's going with kind of open source and some of these open architectures is we're starting to swim sideways and get out of that thinking that I will win if I lock people in. The reality is, open is kind of the new way of driving, faster development, and someone will out-innovate you if you don't think about it. Granted, obviously you guys are all ICS professionals, so you've got to balance the needs of the business and maximize uptime and safety and things like that. But the reason I wanted to give some background is that the world's changing at this conversion point. As kind of IT comes down and OT comes up for edge. And I'd also say that edge inherently has the cloud in mind in some fashion. People say edge computing. I've been doing edge computing for years. Well, those are legacy on-prem apps. Modern edge computing, this distributed nature, it's a symbiotic relationship between the cloud and the edge. Even if you run completely disconnected on-prem for security reasons, safety, mission-critical operations, you will increasingly at least use more capable resources upstream to train AI models or do some sort of pre-processing or post-processing with an air gap, whatever. You're using that spectrum overall. But how do we prevent, kind of lock-in, at the out in the field where you're driving trucks to fix stuff? So Linux Foundation, been around for a long time. It's not just about Linux. There's a lot of different projects within it. If you haven't been involved in Linux Foundation, there's an organization called LF Edge, or an umbrella project within Linux Foundation, very similar to Cloud Native Compute Foundation, CNCF, where Kubernetes was born, and a lot of different projects are coming. LF Edge is all about how do I build a collection of projects that are complementary, we start to kind of harmonize over time, and provide an open framework that's modular, both at the infrastructure plane and kind of getting it to application frameworks to make it really easy to develop edge applications, and so you can focus on value, not reinvention. And so, I mentioned some of these kind of already, but like three of the principles that we're working through in LF Edge is, number one, make sure you abstract your data and your domain knowledge from infrastructure. Open infrastructure is where things are headed. You will differentiate based on your knowledge, unique services, how you deliver compute, and just how you deliver solutions. necessarily unique hardware and software. You will not win by reinventing the plumbing. That is not the world today, especially going forward. As mentioned, you want to decouple all of your edges, wherever the sources of data are coming from any given cloud, as close as possible to the edge location as you can, so that all permutations, whether you're keeping it on-prem, you're going to a public cloud, you're going to some hybrid scenario, all permutations work, and you choose what happens. If you fall for the easy button early on, then the multi-cloud strategy for the cloud players is basically send me all your data, and then you can pay me more money to send it wherever you like. You want to be in control of that. And then this notion of extending cloud-native principles as far out to the field as possible. Basically the goal with Edge and where we see things going, of course we've got ICS systems and we'll see some evolution, but we need to make sure we protect these things, and we'll talk more about that at this intersection point. But the whole point here is, how do I extend the easy button of public cloud where all I care about is resources? Do I care what that server looks like out in the back end? I don't even know what it looks like. It's compute, it's memory and processing and storage. How do I extend that easy button experience as far out into the field until it just breaks? And that's what a lot of the projects within LF Edge are working on. We're going to talk, of course, specifically about EvoS, and I'll do a little highlight on Alvarium, but definitely recommend checking out LF Edge overall. There's a lot of activity happening, a lot of companies involved. And one thing I'll note is open source does not mean that you're giving away all your IP. It means that you're sharing investment on the plumbing. That doesn't matter. It's not differentiated. And it also helps drive interoperability. So think of EvoS as do for Edge, this distributed edge that I talked about. Do for distributed edge what Android did for mobile. Create an open operating system, drive an ecosystem of hardware and software around this common foundation. And the moment you pick an operating system for Edge, you're wrong to a bunch of people. And so the point here is create like this really curated universal shim that sits below your choice of applications. Supports virtual machines and containers, so you can use legacy stuff. It's not like all about, hey, you got to drop everything and scrap it and go straight to containerized workloads. Meets the security needs, which we'll talk about much more, of course, and expose it to the outside world in an open API. So this API is driven through the Project Eve within the Linux community, completely vendor neutral. You choose the controller that you want. There's a basic open source version of a controller, remote controller in the project. And that controller, I say cloud managed operating system, which is where there's super high value to at least orchestrate from the cloud, even if the data stays on-prem. This is not about the data path. It could just as well have an on-prem controller. But the point being is that EvoS has been architected by that community for distributed edge computing, and we'll kind of talk about what that means. So Eve is not just Linux, just like Android is not just Linux. There's JVMs and different components within Android. Eve is Alpine Linux, but it's been wrapped up around a modular hypervisor architecture. It supports Zen and KVM today. We've done prototyping in the community with Acorn. There is this notion of that kind of physical to virtual separation of concerns as OT and IT principles kind of really come together. That part's early. Right now it's more about how do I provide flexibility, those kind of data center architectures, but while also meeting the needs of Edge, and bring it down as close to the controls layer as possible before you just have to go embedded. So Eve is this bare metal shim. It's 512 megs of memory and disk, so it can run on a gateway hub router server. I don't care. It's a box. Could be ARM, could be Intel, or x86. It could be have GPUs and FPGAs. Doesn't matter. Eve is a bare metal shim, abstracts all of the hardware complexity, just like you would see in a data center solution or the cloud, where now, once it's out there, there's an easy-to-use API that it's just resources. I need this much virtual memory for this application. I'm going to dedicate this amount of storage for this application. And we'll talk about some more of the granular functionality, but it is really about give me easy button for resources like I see in the public cloud, but do it on-prem, like right, all the way down to right above the controls layer. For deploying different types of applications. It could be your historian, it could be SCADA stuff, HMI kind of in the legacy sense, and then of course more and more people are starting to experiment with machine learning and AI and stuff like that, but any combination of apps. There's always 2 copies of Eve running at a time. That's part of the reason for the 512 megs of memory footprint. Blue-green partition updates, eventual consistency model. I phone home as a box. I phone home to my controller. I say, hey, what am I supposed to be running? It downloads the deltas, does it in the green partition or the B partition. Only if successful does it flip over. Pretty common practices, but a lot of the stuff that we're seeing in IoT is, I got Linux and Docker. It's just super basic stuff, and it's just not built for uptime, not built for the needs of both the OT organization and the IT organization. It virtualizes all of the resources. This is how it presents it up to the applications. It can literally pass through hardware virtually to where the drivers can even be in the operating systems and VMs above. So lots of different features within the architecture, and again, very much built for this unique operating model where I want to use IT principles, I want to protect my critical systems, I got to assume that I'm going to lose connectivity. Someone can walk up and touch that box, and it's built into the zero trust security model. So I mentioned, any application format. Moment you choose an operating system for Edge, you're wrong to a bunch of people. Of course, I'm telling you to choose an operating system, but the point being, it's a universal shim below. And so then you can run your choice of it could be legacy Windows apps. You don't have to migrate. It's lift and shift up front. While I'm investing in things like containers and stuff like that, we see a lot of companies that are using Linux out there, organizations using Linux. I've built a curated stack that I'm running out in the field. I don't want to change it. I can migrate it over, and it just sits on top in a virtual machine above that shim layer. So really, any combination of apps and guest OSs is the whole goal here. So you have a transition path from your current investments to more modern containerized software. You really built around flexibility. So the key here is, we've seen a lot of proprietary solutions. In the data center sense, we've got proprietary virtualization solutions. With their controller, you're locked into that ecosystem. Limited hardware support because when it's proprietary, that company has to pick up the phone for supporting anything that's out there. But good solutions. Agent-based solutions. The sell is, oh, here's my agent. You can run it on any operating system you want. But the problem is if you don't do really tight integration between that OS and the agent, you will brick that device in the field at some point, and you're going to have a security issue. So with EveOS in the community, what we've basically done is built the agent into the operating system, hardened it, wrapped it around a really robust zero trust security model. Because it's bare metal, you can't brick it. And so I'm a tech. I don't know anything about IT or whatever. Like I grab a box with EveOS off a truck. I plug it in, power and networking. It bootstraps down to the root of trust, so say TPM, creates a crypto-based ID for that box from those credentials, and now you can no longer log into the box locally. You do not have username and password. It goes to its controller and authenticates to its controller, does all the certificate exchange. That controller you have to go through now, which is all logged, and you do role-based access control, however you want to build it out. All actions now go through that down to Eve. Measured boot, remote attestation, make sure that it's everything checks out. Of course, data encryption at rest and in transit. Distributed firewall, I'll talk about next. Because it's bare metal, you can shut off individual ports remotely, USB, serial, whatever is on the box. If you don't want people tampering locally, even though they're going through that central controller, you can completely lock it down. Of course, you can then deploy protocol inspection apps, advanced threat detection, SD-WAN on top, as applications. We're seeing more virtualization around that by the day. And then the central console you would use traditional role-based access control and logging and things like that. But it's as an operating system, it's really built to meet the needs of both OT and IT at the edge, all the way down to silicon, and done in a curated fashion and make it easy to use. So the distributed firewall, very similar paradigms that we would see in data center solutions, is as that bare metal shim through the API, you can govern saying, I want this application to only talk to that Ethernet port. These two will share that one. This one is dedicated to those CPU cores, GPU, whatever. Very, very granular policy-based control, failover between networks. This app can only talk to that IP address or the whole box itself. Helps you do software-defined segmentation on networks, to work through the various different layers of a controls network up through the IT stack, if that's what you're doing. So the whole point here is, Zephyr as an open source project would be focused on embedded devices, microcontrollers. That's a whole separate scenario. We've got all these data center tools like Ansible and Kubernetes, and you've got things from the likes of Red Hat and whatnot. Really great solutions, but their relevance for distributed edge starts to kind of drop off as you go to the left because they don't comprehend managing the box. They don't comprehend the scale factor, and they definitely don't comprehend someone else actually being able to walk up and touch that box. They assume that you're in a physically secure data center. So Eve, what we've done is architect it, from the ground up to be as light as you can go until you just have to go embedded, and then its relevance starts to drop off as you go up, but it becomes like this sort of universal foundation for all these different tools and the applications that you have as they come down. And the whole goal is, again, to extend the public cloud, easy button as far left as possible until it just breaks. So all of the breaches, there's so many more that we've heard of. They're all related to, again, not to trivialize it, but usernames and passwords that are compromised, too easy or just not even possible to change username and password, lost credentials, and then really poor network segmentation, across, the case of the retail breach with the HVAC, the Stuxnet, of course, insider attack. All of these types of breaches that we've seen where it's an intersection between kind of like the internet, the IT world, and the OT world, they all could have been prevented with this type of operating system at the base, the right applications on top to watch for traffic and whatnot. And the whole goal is how do we make it usable, easy to use, while also offering protections for these types of threats. Okay, so let's talk advanced class real quick. Once you get past the security elements, then there's this whole notion of where's my data going and how do I capitalize on that data? A lot of people don't even know where their data is going. You might as well put it on a milk carton and have you seen me? But where we see things moving, so IoT drives more data, then you get the bill for cloud, then all of a sudden you're talking edge, distributed compute. But where we're going, where we think, what's advanced class is this notion of interconnected ecosystems. All of these different use cases, whether it's within my manufacturing, my industrial operations, connecting to my supply chain to consumers, retail crossover into the home, smart cities, all this stuff, eventually things are increasingly interconnected, but you have to build trust into the data itself. You cannot do it one by one relationship. And so it's all about all these things being interconnected over time. Project Alvarium, which is a project alongside LFEdge, or EvoS and LFEdge, it's a new project around data confidence fabrics where you take layerings of trust insertion technologies like open operating systems, immutable storage, yes, a distributed ledger, but that doesn't tell you if the data is real, it just tells you where it's been, authentication, all these different layers. And the framework binds all that together with an algorithm that scores confidence. You can send data out into networks with measurable confidence attached to it, and then do exchanges based on your risk tolerance, privacy versus IP protection and value, and you set the balance. So definitely, kind of forward-looking stuff, but we'll never get to the real potential of digital without investing in open foundations today, going forward. So I'll wrap up. So Edge is a continuum, similar principles, necessarily different tools across the spectrum. It's very much about education. A lot of people will tell you, oh, you can use, here's my magical solution for everything. Not going to happen. Of course, we all know usability is important for success long term. And it's about how do I get the easy button, but also avoid lock-in. Open source is definitely about driving more differentiation, and it's all about preventing lock-in, as well as let's invest on the common stuff, the plumbing, where we can focus on differentiation. Obviously EvoS is purposely built for distributed edge for all the reasons mentioned, and I think longer term this notion of trust fabrics and interconnected ecosystems, if you look at it, it'll turn security from a cost center to a profit center long term. Very similar principles, but long term you can drive new types of value, as ICS professionals. And of course, there's a lot of considerations. You got to protect the critical assets, but the world is changing, and these types of efforts that are hitting the convergent points, I think, are really important to check out and see what makes sense for you. But with that, that's my time. I appreciate you guys listening, and enjoy the rest of your conference.